All right. Thank you so much. And thanks everybody for being here. And special thanks to our amazing panel here that we put together to just like geek out over data lake houses and kind of like understand everybody's journeys here. So that's exactly what we'll cover today, which is, our panel has built some of the largest data lake houses in the world and been operating them for quite some time. And we have Satya from Walmart, Karthik from Uber, Balaji from Robinhood, and also I'm Vinoth Chandar. I'm founder CEO here at Onehouse, and I'm also the PMC chair and the creator of the Apache Hudi project, the earliest data lakehouse technology. And let me before we get started, maybe do like a quick round of intros, starting probably with myself. My own journey. So I was part of the team that built the world's first data lakehouse at Uber back in 2016 to address some of these real-time transactional data, and then how do we kind of integrate it into the data lake, right? So our nerdy term for this was called transactional data lake back then. So we built the first data lakehouse before the term existed in some way. So we donated the project, to the Apache Software Foundation. From there, a good 6 years, spent also, growing the project, the community, and helping a lot of organizations build data lakehouses out there. On the Onehouse journey, 2021, decided to, found a company around this. As the technology category became like more mainstream, we felt like we can create a lot of value by, bringing more managed services around, while there are plenty of open source ways to build the data lakes as well. And quickly about Onehouse, we are been fortunate to have like a really world-class team of data experts here at Onehouse, and we are super committed to open technologies. We created Hudi before Onehouse, and we've since created another project called Apache Xtable, which brings kind of cross-format compatibility and what we call like the universal storage layer across the industry. And being again humbled to have some good kind of light shine on us in the short time that we've been a company at. So enough about, I think, us and ourselves, but turning our attention more importantly to our panelists today. I want to basically, go over their roles in their own words, kind of explain their data lakehouse journeys, how they get started, how did it evolve, and what are the critical use cases, any shareable stats, interesting data points, and anything. So starting with maybe we'll kick it off from Satya. Satya, you lead a large part of Walmart Global Techs and around data. So maybe please help us get to know you better, and also share your story here on how you ended up deep in the space.
Sure. Thanks, Vinoth. Hey, everyone. Good morning. So just to kind of give a brief intro on me, I think Vinoth covered. So I'm a senior distinguished architect at Walmart Global Tech. Walmart has, with our diverse nature of business and different ecosystem from store to e-commerce to club business, we generate a lot of diverse data sets. And recently we have gone a lot more towards event-driven architecture, and we have a very high velocity streaming data coming all across. And that kind of poses a challenge to kind of really process that data at the speed. A lot of interest and the demand to do more real-time data decision making, data-driven decision making, as well as we wanted to reduce the time to analytics for rest of our data consumer. And that's where we started getting into a journey to the Lakehouse. One thing is very critical for Walmart just because of the size and scale. The technology we choose, the technology we invest makes a significant impact so that we kind of adopt it across the board and bring the benefit. And then that's where we kind of give a lot of due diligence on selecting the right technology and choosing the right technology. And just moving forward, right now we have kind of a lot of significant workload is moved to the Lakehouse. We have made significant progress. Ecosystem is still evolving, and we are leveraging kind of a Lakehouse pattern across our hybrid cloud ecosystem. So we have on-prem Azure and Google, where we run the analytics. And kind of that's the state today. We have moved significant part of our workload to the Lakehouse.
That's awesome. I think you are all like pushing some real serious limits there. I think from the scale at which operate for our readers out there. I think commonly people talk about like Fortune X, right? Walmart's Fortune 1. So the absolute scale that the business operates with is like really fascinating. Thanks for that, Satya. And just quickly, let's hop over to Karthik. Karthik, you are running probably one of the biggest data platforms out there that's built on top of a Lakehouse. So maybe enlighten us on what your journey around the Lakehouse has been so far. You're muted.
Yeah. Thanks for having me over. Appreciate that. So my big data journey started when I joined Uber about 6.5 years ago. I worked predominantly on microservices at Amazon AWS until then. Moving from that kind of a request reply and a millisecond response time world into the big data world was a significant shift, right? But coming in, it was pretty interesting. A lot of foundation layer was kind of established for me at that time when I joined Uber. I think, Vinoth, you had an important role to play there in setting us onto the Lakehouse path and kind of directing us towards the journey. So I would like to pick your thoughts as well on as we go through this webinar. But yeah, so we had already started on this data lakehouse architecture. All the data used to land in this raw data sets, so that's what we call. And then all the computations, be it your curated data sets, what we call as golden data sets, your fact tables, your dimensional tables, all of them are computed out of this. Regulatory reporting happened through the data that was in this data lake. Your AI, ML training data, everything was present in the Lakehouse at the time. And then we had other fringes as well, where computation was still happening through other data warehouses. But we slowly got onto the path of making sure that our source of truth was always started in the Lakehouse. I mean, Lakehouse was not coined at the time, so we kept calling it data lake, but then eventually transformed into that. But that was the direction that we were always growing. And there was, we usually think about batch data compute as something that serves, that comes later on in the business play, right? Something that is used to make decision making towards the V end. But that line started to blur. We started to power some online business use cases as well, like payments, which actually happened through the data store that was stored in the data lake. So moving into the data engineering, that was more like a hot seat for me, which was kind of critical for the company and critical for some of the key use cases that we were running. And for Uber, data was a key differentiating factor. I mean, we were relying on it to make very important decisions, and that couldn't go wrong. So it was a pretty interesting place to be in. And operating that was a beast. It was a hard problem, especially in an environment where failures, fault tolerance, they are first-class citizens, right? And I remember many days and nights that we were up just to make sure that things were working. It was a pretty interesting time. And about 2 years ago, I started managing the Hudi team as well, right? Which was the product that Vinoth actually started. Right? It was actually born out of the needs for solving the upsert use cases within ingestion, and then it evolved into something larger than that, kind of becoming the foundational pieces for the Lakehouse. Today, we also use it for derived data ingestion. Right? So actually, outside of raw data, creating the curated data sets, and many, many more. The scope has increased tremendously. It has made incremental ETLs possible, which reduces the cost significantly improves data freshness. It opens up a lot of possibilities that wasn't readily available before. And what we are working towards is that there are a lot of opportunities and work to be done in this space. We leak a lot of details about the Lakehouse to the customers today, right? Customers have to think about layout, file sizes, sort order, etc., so that their applications are reliable, efficient, and whatnot, right? But we want, through table services, we want to abstract many of these away from the customers, similar to how databases hide many of its internal details, right? So you just put data in, you take data out, and that is it, right? So everything else is taken care of internally. That's what we want to work towards. And at the same time, we also want to make incremental ETLs mainstream, right? So we want them to be a first-class citizen so that we unlock a lot of business opportunities. So that's on our mind, and that's what we're working towards.
Got it. Got it. That's like a very detailed, like, breakdown. Thanks for that. And yeah, I remember the early days of actually scaling data as, when Uber was growing 4x year over year at like, $1 billion kind of like, rates. Yeah. It's like fun journeys. All right, hopping over to Balaji here. So Balaji, I think you've been part of this journey as well. You're like a Hudi PMC member, so you've been like deeply involved in the project there. But I'm curious to learn about your journeys at like Robinhood. Which so my first job out of school was working on a hedge fund trading platform, so I can understand like the different beast altogether. Like, so allowed to kind of like understand maybe like how your journey has been unique from that perspective and so far.
Yeah, sure. So yeah, hello everyone. My name is Balaji. I'm currently a tech lead in Robinhood Data Lake Infrastructure team. There actually I'm lead in team in building and operating an ingestion platform for ingesting data from various online data sources to the Lakehouse. Of late, I've also been involved in leading the data governance effort and GDPR compliance for the Robinhood Data Lake. So regarding the Lakehouse journey, so yeah, let me first paint a picture of how it was before I joined, and then I can talk about like what we did after that. So in Robinhood, we have this Postgres RDS as the main online data store, and Amazon S3 as the storage for the data lake. So when I joined Robinhood, we had this like usual nightly snapshots taken from these online tables using live read replicas, and we write them to S3 as like plain Parquet files. So you can imagine, right? There are a lot of read and write amplification here. Like there is a lot of bottleneck on the source database, and basically, like we had like a really large data freshness issue, and we were not able to support intraday or near real-time use cases that are required for many of our applications that we were thinking to move towards the Lakehouse. And also, since we were not using any Lakehouse features, do not have any asset semantics or anything like that, which resulted in data quality issues as well. So after I joined Robinhood, we built this near real-time Lakehouse platform using incremental CDC approach, using Apache Hudi as the underlying platform here, which helped us to bring the data freshness from 24 hours to 15 minutes for critical data sets. So yeah, so just to give us some numbers, like, so we have around like 2,000 tables, out of which like 5 to 10% are very critical data sets with tight SLA of 15 to 30 minutes. So apart from that, like so we have in Robinhood, like we not only use the Lakehouse for usual data analytics purpose, we have some critical product use cases such as brokerage clearing and statement generation and things like that. So reliability and data quality is like super critical for such pipelines. So we again, like we use this Lakehouse for asset semantics using Apache Hudi to ingest data reliably and to power these kind of use cases. So finally, like we recently went international by supporting UK customers. So another important requirement was to bring GDPR compliance and like other regulations into the Lakehouse. So supporting data deletion is like very critical technical requirement. And again, like we built the data deletion strategy in the Lakehouse using the masking approach and Apache Hudi, relied on that to have basically the efficient absurd capabilities to delete data. And so this has been our journey so far.
Got it. So folks like who are tuned in, you can already tell how much this panel has to share. So I'm waiting to. I think we covered, like, I feel like we covered a lot of ground just like in the intros and a lot of different use cases. So I'm waiting to dig in. So let's go to Satya. Satya, Walmart has like a massive data footprint and also guessing a large spectrum of systems, right? So what do you see as a key benefit that this data lakehouse provides or enables when you compare to like a data warehouse or even older generation of data lakes? What does it give you that you couldn't achieve with the older models, in your opinion?
Right. Yeah. Sure. Sure, Vinoth. So just to give some glimpse on the size and scale, right? So we are hundreds of petabytes. We run like 600K plus cores to just process the data, right? So it's a massive amount of data. We have multi-cloud. We have our own private as well as we are in Azure and GCP. So this is like a very hybrid system where I did talk about earlier, like just sheer increase in the event-driven architecture. The retail ecosystem is where update is inevitable, whether it's a journey of an order or returns or whatever happening, we're getting continuous streams of update. So for us, first of all, it was becoming very, very difficult to manage that volume with the traditional data lake or the batch-driven data lake approach, just because of the sheer write amplification and the number of partisans it will go span across and update. It was just becoming like unmanageable, and right at the time where the technology was also evolving, so that it was need of the hour for us when we adopted. The moving from there to it not just help us manage the processing of data, it definitely improved with the incremental data processing, the upsert support and so on. It reduced the processing cost for sure compared to traditional way of data lake or managing data lake. At the same time, it improved the query performance significantly for us, more from a 3-tier ETL architecture to directly exposing data at the right Lakehouse layer, which also empower like the data analysts, the data science community. They just don't need to wait for them, and kind of improve time to analytics for us compared to traditional, like where you manage the data in Lake and then move it on from there to warehouse. And then not just that, making sure, so the ecosystem is so that schema evolves very fast, the way retail business is, right? So even that we wanted to make sure the format or the storage layer should able to kind of capture that. And then definitely bringing the semantics of the whole strong type, making sure we are getting ACID compliance, the caching, the partitioning, ordering, and all that. It just improved the query performance at the scale, which was not possible before. So that has been our kind of a journey, and yeah, that has been the unlock and enabler from the Lakehouse.
Got it. Amazing. There's like a very subtle point here, and I think this was like our watershed moment at Uber as well, which is I came from LinkedIn, so we're used to like we had a big data lake, we did a lot of analytics and like data crunching. But the thing is, we get into actually processing transactional data. It actually turns from like not an analytics counting problem, but it's actually like an actual processing problem where you need to join a lot of things like correctly, and then it's almost like what used to be in my first job, like a back office clearance, like this kind of thing, like a business reconciliation activity that is ultra critical to the entire business, right? So I think that I'm seeing some shades of kind of like what you described there. So yeah, thanks for sharing that. Switching gears completely, actually a little bit, maybe like up leveling it a little bit, go to Karthik. Like Karthik, you're part of a company which basically probably like build a lot of the infrastructure, probably one of the last of the big companies who build that much on-prem like in-house infrastructure, right? So a few years ago when we were starting, like there were no fully managed like Lakehouse products out there, and then the ecosystem's like catching on, and your team at Uber has built like a large in-house data platform, right? So what levels of effort and time were required to build your own, like roll your own data lakehouse? And then looking outside, right, for folks who are starting out today, how do you suggest to think about like DA versus fully managed? You touched upon a lot of like daily things like operating these things and making sure the business criticality and stuff. So maybe just like your views from the inside looking out, maybe share your perspectives on that. That would be great.
So that's a question that I can ramble on for a long time. I'll try to keep so anyway, about the first question, right? So about what it took, what it took for Uber to actually build something like this, right? I mean, you had a first-hand view of how all of this started at Uber. Right, so I'll give it a shot, and some of the key decisions predate me, and you can feel free to add on if I miss something. Right? Uber built one of its first, the first Lakehouse, as it's coined today, right, over 6 years ago, and this was way before the term was coined. Right? For the get the data in and get the data out, as in get ingest and being able to query with the other query engines that we were using at Uber at the time. I think it took about 15 engineers and about 1.5 to about 2 years to get that going. But to me, that was just a technical problem, right? But on the outset of that, it also required a bigger shift in thinking about how producers and consumers of the data interact, right? There were a lot of other tooling and systems and processes that were built around this framework so that, the data ecosystem as such was reliable. The data that can be trusted, right? All of these things became important, right? And that was a significant top-down push. The leadership was super supportive with the direction, and they were keen on seeing this through, right? Data producers, had to think about changing the schemas, right? So something that they did not have to think about earlier on, right? So we used to have schema lists, right? So unstructured data is super cool. It allows you to iterate fast. But when it comes to building a lot of products, and once your data gets fancy and once customers start realizing the value of the data that you have, they start building new things on their own, right? So you don't even know what you're trying. How many other customers are relying on the data that you have, right? So there is a significant disconnect between the producers and consumers. So there is a lot of stuff that actually went in to make sure that producers have some sort of forethought, have some binding contracts in terms of schemas to go through. And this was something that kind of spread throughout the organization, right? So not just across data stores, even through event streams. And I think that was a key, that was key in actually making the data ecosystem at Uber where it is today. In my opinion, it's a very structured and organized way of thinking about the data ecosystem in general. And since then, we have been building platforms to suit business needs, right? So we have been iterating on the Lakehouse just for keeping in step with the business. With asset transaction being a part of it, multi-writer support. As Balaji mentioned, GDPR support came, and there were a lot of other compliance requirements requiring encrypt the data. So we had a lot of pipelines encrypting the data behind the scenes while ingestion was actually happening. That happened. And then we were writing a lot of small files, which created a lot of operation issues. And then we had a lot of offline operations, merging of the small files together. Queries were expensive. We had to think about different ways to making queries cheaper, different sort order, all the smarts that the query engines can use. All of these things followed lockstep, but that's something that we are still evolving on, right? So, but the core piece of it kind of took about 1.5 to 2 years to build.
Got it. Yeah. So the second part, I'm also I'm curious about the build versus buy angle. What would you go with all of this again? Or would you do something else? No.
Well, it's quite easy to say it depends, but I just want to throw a little bit of color so that people do think about it, right? So, whatever solution you pick, it should cover your current business use cases, right? And it should also be able to support your evolving data needs, right? Being in the low usage to the medium usage is one thing, but when you're kind of getting your use cases towards the fringe of what the technologies can support, that puts you in a hot seat, right? So things are going to break. You're going to see a lot of operation problems, which would also mean that you need a lot of expertise. You need a lot of support to be able to deal with that, right? That's something that I would want folks to think about, and that's always on my mind because scale and cost are two of the key things that we constantly think about at Uber, right? Can we sustain for the next 2 years? What is required for us to, what should we do now so that we can sustain us from 3 years out, right? So that's a constant thing that we always think about. We constantly evaluate the technologies that are out there, right? And even with Hudi and the spaces around Hudi, we still do that to make sure that we are using the right technologies for our company. But in addition to your business use cases, some of the other things that you have to consider, that I would suggest consider, is integration and interoperability across various data products and tools, right? So there are a lot of tools that are out there today, right? In the data ecosystem space, even outside of Lakehouse, right? So you have BigQuery, you have Spanner, you have snowflakes, interoperability, if that is something that you desire, that's something that you have to think about. A long-term support is something that something that is a key. Cost, scale, and as I said earlier, it may be easy to get an OSS product deployed, open source product deployed in a DIY fashion for your needs. But if your business needs evolve to be more complex, you would need folks who are experts in that space, and that may be very hard to find. Right? At Uber, we have always been following the business, right? So, and we have been democratizing the data across engineering, data science, and ML community, whose use cases are very different. So most of the cases, we leverage whatever open source technologies that are out there wherever possible, and we tend to fill in the gaps by building things in-house, right? And in some of these technologies that we use, we constantly push the boundaries of some of the products, open source products that we have inherited, right? So be it HDFS or even Hudi for that instance, right? And then these things, these are problems. It kind of becomes a challenge for us. It also becomes opportunities for us to innovate, which we do and we contribute out to. Right? And we solve all of these problems with our in-house expertise. So these are through a lot of things in there, but some of the things to think about and internalize before you make a decision. But cost and scale, for me, because I see that every day, to me are the biggest things that I would like for folks to think about.
Got it. Cool. That's very interesting, and also thanks for covering all the platform components that you need to actually operate the thing, right? Because the biggest thing for me in this journey, what I've realized is whenever I enter conversations, people are looking at me like a Hudi guy or Lakehouse guy, something like that. But from the other side, when you're building some of these things, I also know the amount of things that you have to build around like a Lakehouse storage per se to actually operationalize a Lakehouse end to end, right? So it's like a non-significant amount of work, engineering and operational that goes into actually doing this. And I think for me that was my biggest gap I saw in the market, which is you either have managed services like fully locked down with like open, like close proprietary formats, proprietary services, or you go to like an open world where you just have to build everything yourself, right? So for that extra layer of platformization is kind of like what is very interesting that you touched upon. All right, so we'll shift gears a little bit more, take it like one level like lower, make it like go into the weeds of the workloads and some technical things here, right? So starting with Balaji, you have this like famous kind of blog now, which I think on Medium about the data freshness aspect of Robinhood's data lake. So and you've been part of database teams before. So typically in databases, you throw more cost at it to get more performance. But in this case, the blog basically talked about how you reduce cost as well as like improve performance. So it's kind of like a double whammy. So maybe like for our audience, help us understand what is very like different about this. How can you be reducing, like improving performance as well as improving cost at the same time?
Yeah, sure. Yeah, absolutely. So, so one of the, one of the common ways to snapshot, right? So an online table to data lake, because that's the main problem here. So is to simply do a full table copy and overwrite the data lake snapshot, a copy of that, right? So this actually sounds like a simple mechanism, but actually it only works for small scale and low frequency snapshotting and is very cost inefficient. So like I'm basically going to list down several issues here. Like, so to make this model viable, right? So we have like, we basically need an intraday snapshotting here. We can't like just live with like a 24-hour fresh data freshness. So we want to go with intraday. So with that, like we have to basically, to make the snapshot copy be fast enough, we have to partition this, the process that extracts data out of the source database, right? So that basically means that we need to partition the key space, run multiple queries together, run in chunked fashion and run them concurrently and extract data out. But the primary bottleneck here is the source database IO bandwidth. So to overcome this, either you configure like insane IO on the like source database, like in our case, it's the RDS side of things, or run like multiple replicas, like to scale the extraction out of it. I mean, either way, like it's like very, very costly and super inefficient. So Yeah, basically there are other practical issues here as well, right? So if you have to go with this intraday snapshot, one is the key space will have skews in it. It's quite difficult to tune them, and for certain primary key types, we won't be able to leverage the database indexes to actually have a proper chunked queries perform optimally. So these are just issues on the source database side alone. So you can also imagine the amount of read and write amplification we need to do. Even if there are few rows are changed, we have to read the entire table and then write the whole data into the data lake. So this is basically, again, like going from once a day to intraday means like the read and write amplification is going to explode even more, right? Because the lower the time period, like the number of rows change will be less, and that's going to affect the amplification more. So, and that basically means that the cost with respect to the storage as well as is going to increase a lot. So not only that, right, on the compute side, we have to provision enough compute to allow concurrent extractions from the source partitions, or also shuffling data to ensure like we create like we don't create too many small files and things like that. So what I'm driving home here is that like the process of snapshotting, even though it looks simple, is very costly and infeasible if you want to try to do this in near real-time data freshness. So in Robinhood, like we had like close to 100 or so databases, and like hundreds of tables per per database itself. So, and a good portion of them are like what we call, let's say, medium size to large size, like few hundred millions of rows and things like that. So, and we have business use cases that require us to support like near real-time ingestion to the Lakehouse. So what we realized early enough during this journey was that like a simple like this paradigm won't work. So we adopted this incremental CDC based approach where we try to pull data from the OLTP, just like very much like how replication works between a master and a replica OLTP store. So by just applying the changes, the read and write amplification is greatly reduced. We no longer are bottlenecked on the source DB side. The compute has to be provisioned only for the change volume, and the overall cost of running this is greatly reduced. But we don't get this for free though, right? So the key functionality we need is this upsert functionality. By moving to the incremental mode, we need to apply these changes efficiently. That's where Apache Hudi like basically had this functionality. Like we basically pulled it, used it for implementing this. Just to give overall picture, like, so we run Debezium as a CDC store to capture changes from Postgres and log them to Kafka. We run the Hudi Delta Streamer platform to apply these changes to the Lakehouse to achieve near real-time data freshness in a relatively very cost-efficient manner. So.
Got it. So in summary, essentially there is a big process that was copying lots of data from here to here. We basically reduce the amount of data copied, which also, and then kind of replicated as well as written, which sort of like speeds up makes the process shorter. So since it's shorter, the data moves faster, better freshness. And it's shorter, so fewer CPU cores, so lower cost. That's kind of looks like the thing. And I used to, again, I used to work at the Oracle database replication team, right? And then like CDC was cool in that neck of the woods in 2010. So the thing that I'm whenever in the Lakehouse space, you still talk about the CDC, but the CDC's capture, right? Change data capture. There is like CDA, which is change data apply. So, in that team, we used to talk about it as like, capture and apply. And then like, there are so many techniques between actually just like capturing and applying. I think in Lakehouse, the thing that I find funny is like, we just talk about the capture, but everything depends on the apply, right? That is where the indexes and what you do there. It's kind of like, I don't know, it's a fascinating nugget for me to kind of like be part of like the relational database world around this whole space. And when I look at the data lake space, I think we still have ways to go to kind of like fully catch up there, I feel. But cool. Satya, I know like I've been like also like wanting to get back to you on this and go one level deeper into your workload shapes and patterns. So, I'm constantly learning like how like different organizations evaluate open source projects. And Walmart did probably the most technical Lakehouse evaluation that I've seen, like where you like wrote down the real workloads, not just like, okay, here is a TPCD benchmark and we ran these queries. It's like, okay, here is exactly, you characterized your workloads, separated out read write performance, and we're like, okay, here is where this is going on, like, so that makes me very curious, like how can you share more about the actual workload complexity? You touched upon a little bit around the late arriving data, and like update spreading partitions, and maybe just like talk about your workload a little bit more, and any advice for our audience around how do you like select different technologies? Like this world has a lot of, we are spoiled for choices today, right? So how do you go about, what's your principle that you use and what you would recommend?
Sure,
Right.
sure, Vinoth. Yeah. So I think just to precursor to that, and I think I did talk about it, right? Just because of the sheer size and volume, taking the tech choice is very critical for us, and that's where we wanted to kind of invest good amount of time once we decided into the Lakehouse journey. I think we took two workload which kind of represent the broad spectrum of data processing. Just now Balaji was talking about, and before that Karthik. So I think one we took which was more of a batch workload on a unbounded data set, which was time partitioned. This is where the late arrival pattern was coming, which was more insert, but then there's certain percentage of upsert coming, and it was trickling into the broad spectrum. The second workload we picked was more into the real time. This was coming out of change data capture. We do have a lot of upstream OLTP systems, NoSQLs and so on, where there's some part of analytics run, but then there's always demand to run a more deeper analytics and so on. And we wanted to do that in more near real-time fashion. So this was the second pattern of the workload, which was more heavy into the upsert coming out of CDC, which we want to kind of put into the Lakehouse and then apply there, right? So this is more a lot of upsert, and this was bounded non-partisan data set. So just to kind of bring the variety into the mix. The first one was more like time partition, unbounded, more on insert, and then there are certain percentage of upsert. Second is more, there's no partition, right? Like imagine a monster dimension, and there are lots of update happening to that. Where insert is also there, but this is more update heavy. So we just wanted to pick the right variety of the use cases so that when we do this, the validation and benchmark, we cover broader spectrum of the workload and pattern. At the same time, definitely we wanted, so this was traditional like arc parquet format world, and from there we were kind of trying to move to Lakehouse pattern, right? So definitely those problem of right amplification and so on were there. So one is like just focusing on to the right and right performance. And then we at the same time, we also looked at the architecture for subtle trade-off into the design and so on. We also connected with the open source community and few other organizations when we were doing this due diligence to learn and better understand the use cases. And then, as you said, right, we kind of put the write as a different aspect and then read as a different aspect. So we do use a lot of open source technology. The ecosystem is also very important for us, right? So we have and we have written a blog around this, which is available in public. So we have like BigQuery, Trino, there are Fling, they're part of Kafka based in JSONs and so on. So we wanted to make sure we pick a tool which kind of support this diverse set of ecosystem supports the querying, performance and latency. Definitely there are other data science frameworks which also need to read the data. At the same time, we kind of wanted to bring various kind of query pattern to the benchmark so that we address like multi-way joins, finding needle in haystack, and things like that. Right. So that was our core criteria, but it was not just about the performance, right? Like as you said, we wanted to look at, and I think Balaji touched and Karthik also touched upon. So we wanted to look at various other aspects. So one is like compatibility, right? So we wanted a tool which is compatible to, let's say, multiple version of Spark, so that we are not forced to kind of migrate it at times, right? Availability, repair, like making sure it is available, repairable in case of anything goes wrong, and so on. We also had cost is very important. So more to real like Walmart workload and the cost measure out of that. At the same time, like more in terms of support, right? The more like the stability of the system, the documentation, community ecosystem around that. A roadmap is also something which was important for us, where we can also contribute and collaborate, right? So these were some of the other aspects apart from just like the SEER benchmark, so that we select a technology which is more meeting to all this criteria, and we kind of pick a right tool which support all of that, right? So that kind of cover how we decided onto the pattern, the workload, and the criterias. And I think the blog covers most of this. We kind of finally selected Hudi as the format to go forward.
Got it. Got it. That's great. Thanks for sharing. And I think like I want to like go back. I think we probably have the time for like maybe 2 or 3 if we squeeze it pretty quickly before we turn this over to Q&A for everybody else. So Balaji, want to get your quick take on a few things. So we care a lot about interoperability at Onehouse, and then like there's a lot of like we talk about like formats because in the Lakehouse, because it's like what we've been used to, right? We're used to thinking in terms of like file formats and all of these things. And sure, the format interoperability with the engines is almost like a must-have, right? But I feel like a more often overlooked aspect are open data services. Meaning, like if you want like a truly open platform, like having a bunch of code, proprietary code working on open formats is not going to cut it, right? So as a large user of, you mentioned the Hudi Delta streamer being used, like that's what I use. As a large user of such a open service, what do you think about this, like open format versus like open services angle to this? This I feel is the one that I am most curious about how the others think.
For sure. So yeah, I mean like yeah, open formats are actually not new, right? So we had at Parquet for like a decade now, and so I would say like there are a necessity, but not any come to close to sufficient for running a successful lakehouse. So when we were choosing the technology like for our lakehouse, like it was one of the like criteria. Like basically the reason being like Robinhood being a financial institution, we are subject to several regulations and are on the hook to demonstrate compliance for such regulations. So and data quality and other requirements were also there. Like so, having an open format gives you a cushion or some kind of an confidence that hey, if we need, like our engineers can look at it and audit and like extend the functionality to need. Of course, like yeah, heterogeneous ecosystem with Spark and Presto being there, like it's important to make it to work with the open format. But this is just like bare minimum requirement, right? So running a lakehouse requires like very much more than an open format. I mean, I like, for example, like so we need a rich set of connectors, right? To pull data from various sources, like can be online database, can be Kafka, can be various other sources, right? And this is not a simple task, right? So if you look underneath, like there are several features required here, like exact once guarantees, deduplication, incremental ingestion, checkpointing, like pluggable transformations, ability to scale easily and be able to run in a standalone mode or in a cluster setting and things like that. So several important features there, right? And again, like secondly, like we have to have the ability to run both streaming and like batch oriented ingestions depending on the workload style and the requirement use case and things like that. So we need that flexibility that the Lakehouse platform has to provide. It's just not the open format, right? And also, if you look at it, like the ton of background management task here, right? Which is we need to basically, for example, we need to make sure that the files are written with proper file sizing to maintain better query performance. The platform needs to like automatically clean up old file versions. So any failed transactions has to like be rolled back like automatically and cleanly, right? So to improve query performance, we need the ability to do like clustering and compaction and also like so if we need, like, we have to do like on-demand index creation to support like evolving query patterns, right? As you can see, like all these services are like needed to run any like production grade data lakehouses. And for us, like this was like one of the prime reasons why we chose Apache Hudi, because it comes with this entire platform here. We are getting this all out of the box, right? So if you have to go and implement this, it's like it's like multiple years of work here, like, and things can, like, what we getting is not only just these features out of the box, but also the battle tested nature, like it's been run in production in other places. So, and that's been the key aspect of it. It's like, yeah, in some, basically like platform is like what we care most about. Yeah.
Got it. Awesome. So yeah, for me, I think originally started like, it's also a testament to how far the community has come along, especially around like Hudi and this tool specifically, because I originally wrote it for a talk, Spark Summit talk in London, because we originally planned to like open source Hudi and then like our ingestion system separately. That open sourcing was delayed, but we announced a talk, so we like wrote it as like a tool here. But then it turned out that it's powering some of the largest data lakes out there right now. So and not a lot of it is like, just like a few people, right? It's a very collaborative community effort. Quickly, Karthik, again, before we cut to Q&A, so similar vein, a lot of attention is paid to open from Intrap and all the stuff, but I think at Uber, we like, it's, you looked at it from like a data processing angle, like all along, right? And then the real value to business is in how efficiently or effectively, easily you can manage these pipelines that are ingesting, transforming data. Uber has innovated probably several steps ahead. You're probably like about the handful of the companies out there who are building fact dimension tables kind of like incrementally, right? So can you share some quickly some key technical contributions, and maybe like maybe like very quickly touch upon like what you're looking forward to like doing more, or what does your roadmap around this look like?
Right. So I think some of these things started off with contributing to the Hudi metadata table, right? So that's a general purpose metadata table that is in actual sync with the Hudi table, data stored on H files. So actually a lot of things, just with most of the things at Uber, we build for use cases. HDFS listing was very expensive. We actually brought down name node multiple times. And as a result, we were big on this metadata table, right? So it essentially helped us solve the problem of, not having to go to the metadata to HDFS for actual listings, file listings, right? So instead we went to the metadata table to get the constitution of a particular table, right? So that helped us. And looking at its success, we built a record index on top of it, right? So that's what makes upserts easier and faster at Uber. So before then, we have been using HBase to maintain that kind of an index for key to the Parquet file to identify the file that we need to update as a part of the upsert operation. So we have fully rolled out record index. We have deprecated HBase, and that has been going strong. So the next step that we are looking into is outside of raw data ingestion. Now we are looking at derived customers, folks who are reading data out of HDFS and are writing that into HDFS again, right? We are trying to solve those upsert use cases. Actually, we are getting to one of the largest customers who are going to be customers of record index within Uber to solve these upsert use cases for derived data sets. So that's something that we are pretty excited about. And traditionally, this was they are also getting on to incremental ingestion, right? So incremental ingestion is another thing that is gaining popularity with Uber. Traditionally, ETLs process all the data, or process the last 3, 7, 30 days worth of data, right? So they're trying to solve the problem of late arriving updates, essentially, right? But that's not guaranteed. I mean, late arriving data could be as way in the back as well. So completeness issues were always a concern there. So incremental ETLs kind of do solve the problem. It kind of gives customers the ability to say that, yes, I have processed all the data that has come across, inserts or updates, it doesn't matter, right? Since the last time my application ran, right? That's a big confidence boost. I'm not sure if you have dealt with issues where customers say, my data is missing. Where is it? Go find it. Okay. This is terabytes of data. It has been multiple levels down since the data was produced. It's been few days since the data was produced. Where do I go look for it, right? So I don't know. It's hard to be in that kind of a position, right? So it's like a head scratching thingy. Anyway, so this kind of gives us the ability to build that kind of a confidence, right? So trust in the data, right? So we are going heavy on that incremental ETL space, combining that with upserts. I think we have the ability to reduce the cost by at least by about 20%, 25%, and freshness by more than 50%, right? So derived data freshness, say hours, or even in a couple of hours, is something that is super cool, that can unlock a lot of potential business use cases, right? So because it kind of ties data from various different sources, it gives you the ability to reduce the time to take action, right? Which is kind of key for many of the verticals that we run here at Uber. So actually, we have this is also available in the blog. We have already moved some of the dimensional fact tables into this incremental ETL model that has reduced the cost by about 25% on the freshness for these data sets by 50%. That's something that we are super interested in, and we are looking for the day where most of the ETLs that are running at Uber are actually incremental ETLs.
Got it. I'm also looking forward to that as well, because I actually started the project in that lens now, completely like going from the start, coming from like, working on like CDC before, like I mentioned, and then seeing the rise of stream processing and LinkedIn, and then having, worked on database. I was like, okay, we need a database, I feel. And then we are like dancing around that fact still, I feel like. But anyways, with that, I think, this is so awesome. I had to actually skip like 3-4 other deep questions that I even had since we couldn't cover, but I want to like quickly drop into questions that we've been getting from our audience, and I'll read them out to you, and then and then see if we can find who the best person to answer them would be. First question: I saw some comments on LinkedIn about Xtable, which is quickly adopted as an incubating project by ASF. How will Xtable influence the future of data lakehouse projects? Do you guys mind if I take this, because I'm on the PPMC? So probably like I can give a. So I'll keep it super short, and so we created Xtable because we also saw the formats, table formats, if you will, being like it's a small part of what constitutes a data lakehouse, and they're being like also weaponized in this way. So we wanted to just bring like as kind of like the originators of the data lakehouse architecture. When the category goes mainstream, we want to make sure the interoperability is there across the spectrum, and people can choose to write with something, lead with something. So it achieves that right now, and then there's broad interest across the board to have like a project dedicated to kind of like interoperability to start with, at least. As an industry, we go from one shiny thing to another, but we never focus on actually setting up good foundations for interoperability. So that, I think, is the place that Xtable plays today. It could evolve into some interesting ways, but please engage on the project if you're more curious about it. Cool. Second one, I want to like direct this to Satya. What are your views on data mesh? Is it evolution of the data lakehouse, or is it going to supplement lakehouses? What, like, I think they're trying to understand how to like relate each other. What do you think?
Yeah. No, I think one is more of the infrastructure, right? The foundation, and while other is more of a ways of working. So I would say Lakehouse will be the enabler, and the Maze is just like, how do you kind of share that ownership responsibility, more domain driven, right? So I would say they are complementary, not necessarily competing things. Yeah.
Got it. I think to get just my pet peeve in, I think a lot of this starts from the fact that the very first blog was written, which is like move from a data like mesh to like moving away from a monolithic some data lake to a mesh. They're actually completely two different layers, right? Data mesh does not replace upserts, late arriving data, like partition, like compaction, all these things that we talked about here. Like it operates like one level down. Like data lake can be a node in a mesh, if you want to think about that this way. Cool. All right. Second one, another question around which is around how close are you to using the same data stores for traditional use cases, such as BI, alongside newer use cases, such as Gen AI? So I will leave it this open to the panel, like who is dealing with like Gen AI and BI use cases. So please, like, feel free to take a stab at it.
Yeah, I can add few of the aspect there, right? So, I mean, definitely with Gen AI and especially vectors, you have dedicated vector databases, but the part where it blurs is where you need both analytical data as well as semantical data or the vector data. So at least in our journey, we are seeing the both requirement merging together and in a need for whether it's a data science workload to kind of train a model or to inference a model, need for a system which is kind of catering to both, right? So definitely both from a lake perspective as well as to other query engines, getting that support together is definitely going to enable a lot more better data science productivity and so on. There are tendency to kind of keep the data, especially even if it is the vector database data sets and so on, into the cloud storage or whatever lake storage is. But right now that's not prime time. Having those support from the format will definitely help evolve the ecosystem and accelerate some of the workload.
All right. I think we are actively thinking about this in the community, in the Hudi community. There are at least like documented cases of people who are modeling vector searches using our current indexes. And so there's like a lot of like, I think creative prototyping / thinking going around this place. So this is like a really good time to engage as well if you're curious about this convergence. Cool. There's a couple of Hudi questions which I will like skip a bit and try to answer like offline. I want to like try to focus on the while we have this stellar panel here, focus a lot more on the architectural things as much as we can. Is there any data platform for on-prem data lakehouse development? Karthik, do you want to take this? Your Uber's, I think, good footprint is on-prem.
Is there any data platform for on-prem lakehouse development? I'm not sure what on-prem means, but
on-prem.
On-prem, I see.
Yeah.
Oh yeah. So I think Hudi started on-prem, right? The evolution of today's Lakehouse actually started on-prem. We were a big HDFS shop. We still are. I mean, I think we have one of the largest deployment of HDFS. So that was our object storage layer. And then we have Hudi on top of it, which kind of abstracts your table views in addition to the high meta store, right? And on top of this, I mean, this is your entire data layer, right? And then on top of this, you have all the query engines, your analytical processing engines, your Sparks, Prestos, Hive, whatnot, right? So all of these things run on top of the data that we have stored here. And then we have analytical engines like Looker Studio that make use of the data that is produced through these query engines to make it easier for customers to visualize the data. Right. And then we have I'm talking about the layer cake here at this point, but all of these things were, inspired from open source or built in-house, but the evolution of the entire data platform happened at Uber on-prem. And then we had a lot of vertical integrations across security, access controls, chargebacks, visibility into cost. I mean, kind of like building a mini AWS or GCP sort of a thing for data customers at here. So that's basically what Uber has been trying to do.
Got it. Yeah, it's a lot of assembly of some of these building blocks, but we've philosophically we've tried to approach it as a platform problem in Hudi, while we have like the rights and the management and then a lot of tooling around it, and then it try to fit into every engine out there so that it can be read. So that's kind of like what I think we have like a detailed blog on hudi.apache.org that goes into some of these principles. I think if you scroll down, it'll say our vision, and it goes like a 20-minute read that we put out like a few years ago as a manifesto. So that's about it. So I think we are on time. I really enjoyed this myself. I got to like learn a lot as well. I want to thank everybody on the panel. Thanks for your time. I know how busy you all. Thanks for taking the time and kind of like sharing your experiences with the audience today. And then, look forward to seeing you all again, and maybe like cover those 4 or 5 questions that we didn't like get to. I guess that those were all very interesting. All right, thank you, folks. Thank you everybody who's tuned in as well, and we'll answer some of these questions like offline.
Thanks, Vinoth. Thanks for organizing
Thank
this.
you.
Thanks, everybody.
Thanks, Thanks,